In theory, I could be paying someone in Bitcoin and just waiting for confirmation because the transaction didn't get included into the blockchain for some reason.
Yep. Yeah. Like there's no guarantee that when you submit a transaction, even if you have all your fees right, like there's no guarantee that it's going to make it to a block. Now, it probably will, but like there's no rule that like gives you that right. You basically have to wait until you get 6 confirmations before, like statistically, you can be like, okay.
Which may or may not go.
Which may or may, yeah. Now, again, like we're talking edge case here. Like in practice, like you're not going to have these problems. Hopefully.
I've seen it take up to like 40 minutes.
Yeah. Yeah, so it takes about 10 minutes to run a block.
Yeah.
So like if you want to have like 5 or 6 confirmations on a transaction, take an hour. But and again, it depends. Like like your use case is going to dictate like what type of security that you want on your transaction.
Like what happens if the miner goes offline?
If a miner goes offline, then
While the transactions for that block are still supposed to be occurring.
so the nice thing about like this distributed system is that like if a miner goes offline, like it doesn't really affect the network that much. Like if a because there's going to be other miners who are going to be like taking that miner's place.
And all the nodes are synchronized.
And so yeah, the mempool of like transactions that miners are taking in to build a block, like everybody has that mempool. Like those like when you put a transaction into the network, like let's just say like you have you're running Bitcoin D on your laptop, and you put that transaction into your laptop's Bitcoin D. Like the protocol is going to do like this gossip mechanism where it's going to saturate as much of the network as it can with that transaction. So the network is going to get that transaction in all of its mempools. And so that means that more than likely there's probably several miners who have that transaction in their mempool. So there could be one miner who has that transaction, and like let's say they even get the block. Like they solve the problem, they publish the block, it goes out there, and then they go offline. That's fine because that block got propagated to the rest of the network, and other miners are working on the next block, and they already know about that block. And then if they went offline before they published the block, that's fine because your transaction is probably in another miner's mempool, and when they solve the block, they'll include that transaction. So we're kind of just like spraying the transaction as far and wide as we can, and that happens pretty quickly. Like it doesn't take like that long to do, but you're basically putting that transaction in as many places as you can, and so there are many miners who are going to have the ability to include that into a block.
And after the transactions get picked from the main pool, like similar to Caustic, how it sprays the transaction, does it also go around and clean up the main pool on the rest of the nodes? Or?
Yeah, exactly. So when so the question is like what happens like to the transaction in the mempool after like a block has happened, basically. So like your transactions in the mempool of all these nodes, and then a miner gets up, they compute a block, they include the transaction from the mempool into the new block, and then that block gets broadcasted to the network. And then so my node on the network is going to say, okay, like I've got this new block now. Oh yeah, and it has this transaction that's in my mempool, so I can get rid of that transaction out of my mempool now because it's a part of the blockchain.
So is the amount of transaction fees you pay the only incentive you can provide to at least assure, not 100% assurance, but as close as they can get to be part of a blockchain, a block that will not get orphaned? Yeah,
like so basically if you want to have the best chance of getting your transaction into the blockchain, you should put a fee on there. Okay. And I think Coinbase puts like 20,000 Satoshis on their transactions. Coinbase, the company. I don't know, maybe they want to make sure that they really get into the blockchain.
Quick question here. How are you? How much time? More slides do you have there?
We're still cruising. We probably have like maybe another 10 or 15 minutes. We can breeze through it if we want to pause questions. I don't know.
I just want to give Atif some time.
Yeah.
So how about 5 minutes? And if there's something that we
let's just breeze through this here. We are running a little late on time. We'll breeze through it, and then if there's any like further questions, like maybe Atif will address them in his more in-depth discussion, then I'll be around this afternoon to talk about this stuff.
We'll be able to see slides.
Yeah, we'll post the slides too. Yeah, for sure. One important thing to know is that Bitcoins have like in each transaction there's a script and there's a scripted language, and you can do all sorts of really cool stuff with it. And it turns out that sending somebody Bitcoin is only one use. Like it is a very simple script. There are more scripts. For instance, there is, so the most common one is pay to public key hash. So this is where I know somebody's public key or I know somebody's address and I just want to give them Bitcoin. I can use that one. There's pay to script hash, which is like I can create a script and I can pay to that script. And people who know about that script can access that money. This allows you to do stuff like smart contracts. It allows you to do stuff like multi-signature. Then there's an explicit multi-signature script type, which is not really in use that much today. Most people use P2SH. So pay to script hash is like the thing that you should be looking at. Like it is the future. Like you can do so many cool things with it. So you need to definitely look at smart contracts and you need to look at pay to script hash. This is like we can walk through this. I can explain how scripts work like offline. It's actually really cool. There's like an assembly-like language within each Bitcoin transaction. This is all the code that it takes to create a transaction. You can see that we import a private key from a WIF. What's that?
Can you make that bigger for us?
No, I can't. I'm sorry. I don't have this one on my console. But you can basically, there's 1, 2, 3, 4, 5, 6. There's 6 lines of JavaScript code that you can write to create a transaction. And when I publish these slides later, you can look at that in more detail. But this is all you need to know. The details here aren't important. Just know that you can create a transaction in as little as code as fits on a slide. Like I said, there's smart contracts. You can create betting systems that don't involve a third party, so you don't have to have a bookie to do your bets, which is really great. Payment requests. Like earlier I said, use an address once. There's actually a support in Bitcoin so that this type of workflow is really easy. It's called a payment request. So if you're building an app in which you want to be sending and receiving Bitcoin, definitely should be using payment requests. In terms of software, like I said, we've been talking about this a lot, but there's libraries, there's full nodes, and then there's what they call payment verification or light nodes. There's also the wire protocol. So Bitcoin Core or Bitcoin D is like the reference implementation. It's what Satoshi wrote and gave to us. And it's what is like the primary software that runs Bitcoin. You can download this and store it on your computer, store the blockchain on your computer. It has different RPC mechanisms that you can interact with it to kind of query the blockchain. My favorite is BTCD. I like to write Go. I write a lot of Go code, and it's a full node that implements a consensus algorithm bug for bug. You can also decompose it into like the wire package. There's a utility package. There's like network packages for it. Like it has everything that you need if you want to do like really crazy and interesting things with Bitcoin. Bitcoin J, if you're a Java developer, this is the software that you got to be using. It's great. Documentation is wonderful. The tests are great. Like it's feature complete. It's really awesome. If you're using Node.js, this is a great library. I've used it a lot and it works really well. And it also has the ability to work in a browser as well. You can browserify it. And then there's APIs. So like Chain.com is an API. Basically, like your Bitcoin software, like Bitcoin D or even Bitcoin J, it doesn't have great support if you want to query things by addresses, by arbitrary addresses. And so like blockchain.info is another great example of like a site that offers an API. But basically, what you have out there is like you want like so whenever you create a new transaction, you need to get the unspent outputs. You need to figure out what is available for you to spend. And so to do that, it requires just like some re-indexing of the data that Bitcoin D doesn't really offer you. So you would look to an API to provide that kind of data to you, or you could build it yourself using Bitcoin J or BTCD. Transaction broadcasting, network propagation level is something that's really cool that a lot of APIs will offer. So like, APIs will connect to all the nodes in the network, and they'll tell you like out of all the nodes that you can connect to, they'll tell you how many of them have the transaction in their mempool. Then there's also push data, so your application can receive data as stuff is happening on the blockchain in real time. And then here is here's the list of resources I put together, and there's probably a lot more, but these are definitely places that you should be checking out if you're interested in developing on Bitcoin. There's a lot of good stuff here. And then also what's worth pointing out is that there's testnet. So there's like an alternate blockchain that gets reset every now and then, and it's a way, and it's really easy to get testnet coins. So if you're testing your application, you want a sandbox environment, testnet is what you should be using. And then I also included here, we put together at Chain, we put together an iOS 8 Touch ID wallet demo, and this code is like meant to be forked. And so if you have an idea that you want to be building an iOS app on top of Bitcoin, this is a great place to start. It has all the basic stuff, pieces that you need, and you can kind of take and extend it to do whatever you want. So with that being said, I think we'll call it there. So sorry to kind of rush through at the very end. I didn't do a great job of time budgeting, but yeah, I'll be around all day. And thank you very much for your time. Oh yeah, and I have t-shirts too, so come find me and I'll get you a t-shirt and a sticker.
Throw them out. Cool, so we'll take like a 15-minute break here. There is some coffee in the kitchen, which is just around the corner. Bathrooms are out in the hall.